This is the solutions video to your rationalizing homework. Okay, remember, rationalizing means we want to get a rational number in our denominator. I know it might get a little cramped, but we should show all of this work. So for number one, this one's easy. Just multiply top and bottom by the square root of 3. Okay, top and bottom because we're just multiplying by 1, changing how it looks. And this should give me the square root of 3 all over 3. Okay, and I know that a lot of us don't, but it's totally okay if you want to kind of write this in-between step of having this radical 3 in the top, and then the square root of 3 times the square root of 3 is the square root of 9. So really I have the square root of 9 in my denominator, but we know that the square root of 9 is just 3. So that's kind of how I go from one step to the other, if you've kind of been wondering that. So for number 2, multiply top and bottom by the square root of 10. So I get 5 times the square root of 10 in my numerator, and then in the denominator that's the square root of 100, which is just 10. Alright, but don't stop there because this cancels. I get a, oops, what happened there? Oops. 5 goes into 5 once, 5 goes into 10 twice. So your final answer should be the square root, oops, wait, my color's mixed up. Should be the square root of 10 over 2. Okay? Put boxes around my final answers, I guess. For number 3, we're going to multiply by the square root of 3 over the square root of 3. Which I'm going to get 4 times the square root of 3 in the numerator and 2 times 3 in the denominator. And 2 times 3 is just 6. But we can cancel because 2 goes into both of these. So your final answer is going to be 2 times the square root of 3 over 3. For number 4, sorry about that, somebody came in. So for number 4, it's a little more difficult because now we have a binomial in our denominator. So here we have to multiply by the conjugate, so you change the operation in the middle. So the conjugate of my denominator is going to be the square root of 5 plus 2. And we're still going to do that top and bottom. And now we've got some distributing and some FOILing. When you distribute the top, you should get 3 times the square root of 5 plus 6. And then in the bottom, the square root of 5 times the square root of 5, that's the square root of 25, but that's just 5. And then I do the outer, so I'm going to get plus 2 times the square root of 5, minus 2 times the square root of 5, minus 4. And these should always cancel down here, the things that have the radicals. That's the whole point of multiplying by the conjugate. So then I'm left with 3 times the square root of 5 plus 6, and 5 minus 4, that's just 1. So there's your answer. For number 5, we have a binomial, so you have to do the conjugate again. So the conjugate is going to be 3 minus the square root of 3. We do that top and bottom. And when we distribute the numerator, you should get 18 minus 6 times the square root of 3. FOIL out the denominator, you should get 9 minus 3 square root of 3 plus 3 square root of 3 minus 3. Again, these terms should always cancel, and they do. So I'm left with 18 minus 6 times the square root of 3 all over 9 minus 3, that's 6. Okay, but remember my favorite thing to do, factor the numerator factors, because I can pull a 6 out of everything. And I'm left with 3 minus the square root of 3. And then these 6's cancel. So your final answer is just 3 minus the square root of 3. Okay? Always simplify all the way. Try and factor and cancel stuff out. Number 6 is just going to be the square root of 12 over the square root of 12. So that'll give me 6 times the square root of 12 over 12. But you simplify, because 2 goes into both of those. I'm sorry, 6 goes into both of those. So your final answer is the square root of 12 over 2. But wait, that's not the final answer because 12 you can break down, right? 12 breaks down into 2 times 2 times 3, and you can pull out some 2's. So that's going to give me 2 times the square root of 3 over 2, and those 2's cancel, so your final answer is just the square root of 3. Alright, I'm going to erase this so I have more room for number 7. Alrighty. For number 7, I need to do the conjugate of the denominator, so that's the square root of 10 minus 1. And now we got to FOIL the top and the bottom. So when we FOIL that, we should get the square root of 10 times the square root of 10, that's 10. Minus the square root of 10, minus another square root of 10, plus 1. And then in the denominator, I'm going to kind of skip a step because I know that the square root of 10 times the square root of 10 is 10. I know that when I do my outers and my inners, they're going to cancel. So I'm not even going to bother writing it. And then here I've got minus 1. Okay, that's just to save space. You should still write out, FOILing out all of the denominator, but I kind of have limited room here. So let's combine some like terms. In the numerator, this is going to give me 11, because I combine my 10 and my 1. And then when I combine these radicals, I get minus 2 times the square root of 10. And then this is all over 9. And nothing is going to cancel, so this is your final answer. For number 8, we're going to multiply by the square root of 3 over the square root of 3. That's going to give me 2 times the square root of 6. All right, you can multiply the 2 and the 3 because they're both under a square root. And then in my denominator, I've got 4 times 3. So this gives me, oops. So now I've got 2 times the square root of 6 over 12, but 2 goes into 12 6 times, so your final answer is the square root of 6 over 6. Alright, you can't break that down because 6 is not a perfect square. You can't pull any pairs out. You're done so. Number 9, we're going to have to do the conjugate. I'm going to erase this a little bit right here. So, and don't forget about these parentheses in the numerator. That's my computer just did that for funsies, I guess. So it means the same thing as all the other ones. So the conjugate is going to be 3 plus the square root of 2. And we're going to do a lot of FOILing here. FOILing the numerator. It's going to give me 6 plus 2 times the square root of 2 plus 3 times the square root of 2 plus 2. All over 3 times 3, that's 9. Again, for space, I know that when I do the outers and the inners, they're going to cancel. And then this is going to give me minus, not minus 4, minus 2. And let's combine some like terms. 6 plus 2, that gives me 8. 2 radical 2 plus 3 radical 2 gives me 5 radical 2. And this is over 7. Can't factor anything out. Donezo. For number 10, we'll multiply top and bottom by the square root of 2 over the square root of 2. So this is going to give me 5 times the square root of 10 all over 15 times 2. So I get 5 square root of 10 over 30, but this cancels because 5 goes into 36 times. So I'm left with the square root of 10 over 6. I need to do the conjugate. Alright, so the conjugate of this is going to be the square root of 5x plus 2, square root of 5x plus 2, put a little blah, so keep it all together. Now, the same thing goes with this, even though it's got a variable under there, alright? The square root of 5x times the square root of 5x, that's just 5x. Okay, if you want, you could write that as the square root of 25x squared, but then you break it down anyways. So this is just going to give me 5x plus 2 times the square root of 5x. And then I FOIL in the bottom. I know I'm going to get a 5x for my firsts. Again, for space, I know that when I do my outers and my inners, they'll cancel. You still show it. And then 2 times 2, that's 4. Nothing factors out. Nothing cancels. This is your final answer. Okay. Now, for the rest of these, well, not the rest of these, 13's okay. Well, maybe a little bit. For the next ones, there's kind of a lot of little pieces that we need to do in order to get to a final answer. Okay? For instance, right now, looking at number 12, before I do anything, I see that this is a square root, so I'm looking for groups of 2, and I can pull stuff out of that because I have 4 A's and I have 3 B's. Okay, so let's just pull stuff out before I even start doing radicals and stuff. Okay, so when rationalizing. So when I pull stuff out, I'm going to pull out 2 A's, and I'm going to pull out 1 group of B's. And then I am left with a B and the 2 under there. Okay, so I just pulled out what I could so far. Okay, now we talked on this before, that division under a square root is the same thing as dividing square roots. So this is equal to a squared b, and then I'm going to break this up into the square root of b over the square root of 2. So I took this, and I just divided it up into 2 different square roots. Okay? And now this should hopefully be a little clearer of how to rationalize this. Now we just need to multiply by the square root of 2 over the square root of 2. And then that's going to give me this a squared b, we can't forget about that, times, this is going to be the square root of 2b all over 2. This is your final answer. Okay, so pull anything out that you can pull out before you start going to town and rationalizing. For instance, if we look at 13, before I start multiplying stuff, I should notice that I have 2 A's under there, and I'm looking for groups of 2. So I can pull an A out. So this is going to be 3 over A times the square root of 3b. Okay, that's nice. The fewer things that you have in your radicand, the better. So now I can go ahead and rationalize, and I'm going to multiply by the square root of 3b over the square root of 3b. Oops. Extend a little bit. So now, in my numerator, I have 3 times the square root of 3b. In my denominator, I still have this a, and now I have times 3b. Cancel the town. This 3 is going to cancel with this 3. So I'm left with the square root of 3b in the numerator, and then just a times b in the denominator. Pump the brakes for 14 and 15 because these are not square roots, these are cube roots. Okay, so I'm looking for groups of 3. Now looking at this though, I can pull out some A's because I've got 4 A's in my numerator. So when I pull them out, I'm pulling out 1 group of 3, and then I'm left with a 2 and 1A in the numerator, and then the 3b squared in the denominator. And remember, just like we did up there for number 12, I can break this up as this cube root, oops, it's starting to look like an A cubed. Oops. So this is A, and then I've got the cube root of 2A divided by the cube root of 3b squared. Okay? Now, we talked about this in class. Remember, when you're doing a cube root, since you need groups of 3, you're not going to multiply once, you're going to end up multiplying twice. Okay, so when I do this my first time and I multiply by the cube root of 3b squared, if you look, I've only got 2 groups of 3b squared. I need 3 because that's my index. Okay, so let's move down a little bit. So now, when I did it the first time, I've still got this a. The cube root of 2 times 3, that's 6ab squared. And now my denominator, I'm just going to leave as the cube root of 3b squared. Oops, what happened there? Times 3b squared. So you can see that I only have 2 groups, and I need 3 groups since my index is 3. So I got to do this again. And now if you look, 1, 2, 3, and that's what I needed. So now my denominator is just 3b squared. Let me extend again. And then in my numerator, I've got a times the cube root of 6 times 3, that's 18. I've got an a, and then I've got 4 b's. And now I'm almost done because 18 doesn't break down. I mean, it does break down, but there are no groups of 3. A doesn't break down, but I do have 4 b's, so I can pull a group out. I'm left with 18ab. And then this b is going to cancel with one of these b's. So here is my final answer. Okay, I know that it's a lot, but I kind of like to show all of the steps, and I mean, you guys could have gone on the back, scrap paper, whatever, but make sure you're showing all of this work. And now let's do 15. All right, same deal as 14. Let's see if we can break anything down before we start multiplying and rationalizing. I've got a cube root, so I'm looking for groups of 3, and 27 breaks down into 3 times 3 times 3. So I can actually pull a lot of stuff out. Let me erase here. So I've still got my 2a over 3x on the outside. I'm going to pull out a group of 3's, and I'm going to pull out a group of x's from the numerator, and I can't pull anything out from the denominator. So I'm going to be left with the cube root of x over a squared. Okay? And automatically, woohoo, because this 3x will cancel with this 3x. Okay? Remember, this 3x was in the denominator. I pulled this 3x out of the numerator, so it stays in the numerator. So these cancel. So now I've got 2a times the cube root of x over a squared, which is the exact same thing as if I wrote 2a, and then I'm going to break this up into the cube root of x over the cube root of a squared. And I've got a cube root, so I'm going to have to multiply 2 times. All right, so let's do this the first time. Multiply by the cube root of a squared, cube root of a squared. So that is going to give me 2a. Now, don't get confused. This 2a right here is just like hanging out in front. If I wanted to, I could write this as, whoops, put the eraser down, as 2a over 1, and I could throw it in my numerator, whatever. All right? So let's see. This is going to be the cube root of xa squared, and I'm going to leave my denominator as the cube root of a squared times a squared. All right, so you see that I only have 2 groups and I need 3. So I'm going to do this again. So now I'm going to have 2a times the cube root of xa to the fourth, right? A squared times a squared is a to the fourth. And now I've got 1, 2, 3, so this is just an a squared down here. And I've got 4 a's, and I'm looking for a group of 3, so one's going to pull out. When I pull that out, that means I've got 2 a's on the outside. And these a squareds cancel, so your final answer is 2 times the cube root of x. Woo! That was a long one. Okay? If I lost you, pause it, go back, come ask me something. Alright? On to the back. And that was just review, 3 easy review questions. Solve and check. For part A, the radical's already isolated, so I can go ahead and square both sides. Remember, this left side is x minus 2 times x minus 2. And over here, I'm just left with 2x minus 1. This boils into x squared minus 4x plus 4. And now I have a quadratic. And remember, quadratics, I always want to get them equal to 0 because then I can factor or I can use a quadratic formula. So when I get this equal to 0, that's going to be x squared minus 6x plus 5. And this does factor into x minus 1 and x minus 6. Hold on. X minus 1, x minus 6. X minus 1, x minus 5. Much better. Whew. Go away. There we go. So zero product property says that x minus 1 equals 0 or x minus 5 equals 0. So I get x equals 1 or x equals 5. For space reasons, I am not going to do the check. Alright, but remember you need to check in the original, you need to check both of these, and I'm pretty sure that we are going to end up rejecting x equals 1. But x equals 5 is good. For B, my radical is not isolated, so I need to move this 2 over first. And then I can go ahead and square both sides. Woo. This is just going to give me 3y minus 2. On the right, I'm going to have to do some foiling. And that is going to give me 9y squared minus 15y, I'm sorry, minus 12y plus 4. And just like for part A, I have a quadratic. All right, don't get freaked out that it's y's instead of x's. You got a square in there. That means it's a quadratic. So let's get this equal to 0 and see if we can factor. So I'm going to get 0 is equal to 9y squared minus 15y plus 6. If you don't feel like factoring, go ahead, use the quadratic formula. Totally up to you. I do know that this factors though, okay? The first thing we look for factoring is a GCF, and these have a GCF of 3. If I pull a 3 out of everything, I'm left with 3y squared minus 5y plus 2. Keeping that 3 out there, the first part of my brackets are things that multiply together to give me 3y squared. Well, there's only one guess for that, and that's 3y and y. The ends are things that multiply to 2. Okay, multiply to positive 2. Well, that's just going to be positive 2 and positive 1, or negative 2 and negative 1. And you might need to go ahead and do some guess and check of which goes where. But this is going to be minus 2 and this is going to be minus 1. So 3 equals 0. That's silly. That's never going to happen. Scroll down here. 3y minus 2 equals 0, or y minus 1 equals 0. So you get y equals 2/3 or y equals 1. I am not going to check them for timing and space reasons, but I do believe they both check. And part C, super easy. You have a cube root. How do you do a cube root? You cube it. So we cube both sides, you get x is equal to 27, and I promise you that that one does check. Sorry this was a long one, but I hope we're all good on it now.